Hello, today I and Tamuna are going to talk about Profibus and Profinet, industrial communication protocols. They are very different protocols. They use different cables and connectors. Let's now discuss both of them and see how they differ from one another. Profinet is an open industrial Ethernet solution based on international standards. It is a communication protocol designed to exchange data between controllers and devices in an automation setting. Controllers could be PLCs, DCS, or PAC. Devices could be I/O blocks, vision systems, RFID readers, drivers, process instruments, proxies, or even other controllers. Profinet defines cycling and acycling communication between components, including diagnostic, functional safety alarms, and additional information. To link all of those components, Profinet employs standard Ethernet for its communication medium. Ethernet cables connect Profinet components within a network, allowing other Ethernet protocols to coexist within the same infrastructure. Besides Profinet, you can employ other Ethernet-based protocols to complement the network, such as OPC-UA, SNMP, MQTT, or HTTP. With Profinet, standard communication and safety-related communications are both achieved by using single cable that significantly reduces wiring and engineering effort. Profibus is also a communication system. It communicates via a serial protocol behind which complex machinery is housed to transport the data reliably through an industrial environment. The protocol defines the message design, access to the network, and fault control. There are ASIC chips available that coordinate the entire protocol. This way, the product developer does not have to be involved much in Profibus to build the field instruments. Profibus has three variants: Profibus DP, Profibus FMS, and Profibus PA. The Profibus DP is one of the two variants that is used the most frequently. For this reason, it is regarded by many experts as the standard Profibus. It is used in process automation of large assembly and material machines, and supports single cable wiring of multiple inputs like sensors, pneumatic valves, smaller networks, complex intelligent devices, and operator interfaces.
Profibus, along with Profinet, could be considered as an undisputed world leader in area of industrial communication protocol. Since Profinet is an open standard, hundreds of manufacturers have developed Profinet products such as PLCs, PACs, robots, proxies, diagnostic tools, and etc. Profinet supports 256 devices using communication paths such as IRT, RT, TCP, IP, and so on. And for the Profibus, it supports 127 devices, and with over 50 million devices installed by the end of 2017, it is well-established technology used in many different control systems. Profibus and Profinet may look similar, but they are really different. In short, Profibus is classic serial field bus, and Profinet is an industrial Ethernet protocol. Profibus networks operate at speeds from 9,600 bits per second to 12 megabits per second. Profibus cable may be up to 1,000 meters long, and shorter cable lengths are required for higher data rates. For the Profinet, it operates at 100 megabits per second, and cables may be up to 100 meters in length. And due to its high-speed operation and response time of less than 1 millisecond, Profinet is ideal for high-speed applications. Because Profinet uses the same physical connection as Ethernet, the standard Ethernet switches can be used to expand the network. And because it is the Ethernet-based, the Profinet can operate on much higher transmission speed than Profibus. Additionally, with Profinet, the cycle time are also adjustable for each device, whereas Profibus has fixed cycle time. Altogether, Profibus is still commonly used all around the globe. However, it is noticeable that more and more companies are increasingly turning towards Profinet systems nowadays. Profibus, let's discuss how it works. Well, Profibus in general employs a master-slave interaction between its network's components. The controllers are always the masters and the I/O devices are always the slaves. The Profibus family consists of 3 versions: the Profibus DP, Profibus PA, and Profibus FMS. The DP is optimized for high-speed and inexpensive hookup. It is designed especially for communication between automation control systems and distributed I/O at the device level. The PA version is designed especially for process automation. It permits sensors and actuators to be connected on one common bus line, even in intrinsically safe areas. The PA version permits data communication and power over bus using 2-wire technology. And for the FMS version, it is a general purpose solution for communication tasks at the cell level, and FMS services open up a wide range of applications and provides great flexibility. Let's now see the Profibus protocol with a reference of OCI model. The OCI has a 7-layer and Profibus has only 3. The layer 7 is application layer, and the layers from 3 to 6 of the OCI model are not used in Profibus at all. And the data link layer is same as security layer in Profibus, and the physical layer is bit transmission layer in Profibus. Now let's discuss that 3 layers. Well, the first one, the application layer, determines 3 different DP protocol functions. The DPV1 is for I/O communication and diagnosis. DPV2 is for acyclic data exchange and alarm handling, and DPV2 is for slave-to-slave communication. The next layer is the security layer. It is known as FDL, the Fitbus data link, and it handles the data transmission between master-to-master devices and also to master-to-master devices. And it adopts the token passing technique and handles both data security and error detection. The third and final layer is the bit transmission layer. Here, the data can be transmitted either by electrical transmission, twisted pair cables, or optical transmission. Now, detailed about the security layer. Here, the data is transmitted in the byte format, and each byte is secured by even parity and are transmitted asynchronously with start bit and the stop bit. The frame has the start delimiter, the function code, destination address, source address, end delimiter, and so many more. This is how the Profibus wave looks like. The figure shows the A and B waveforms, for loading of the Profibus transceiver and common mode voltage of 0 volt. Both slave and master Profibus test applications state that the differential voltage between A and B lines should be minimum 4 volt and the maximum of 7 volt. And difference of the amplitudes should be less than 0.5 volts. Now about Profinet. Profinet connects process devices like sensors, actuators, and so many more. It complies with the Ethernet standards IEEE 802. And that means that we can have a printer and a flow meter on the same network, which is amazing. However, Profinet runs much faster than the regular office Ethernet, with cycle rate in sub-milliseconds. To explain how this works, we have to again turn to OSI reference model. As mentioned, OSI model has 7 layers to connect 2 points in a network. The Ethernet standards simplifies that 7-layer model to 4 layers. We have Ethernet, same as physical and data link layers. We have IP, same as network layer. We have TCP or UDP, same as the transport layer, and we have other protocols for application layer. And Profinet actually uses those 4 layers, and sometimes not all 4 of them. For example, the real-time Profinet skips the network and transport layers, and that makes response much faster than the standard TCP or IP model. Profinet's network can be a complex collection of stations from the digital I/O devices to pneumatic actuators, to laser scanners, and so on. And that list can be endless, and it grows every day. But within that complex network, all Profinet components operate with three different roles. They can be either devices, controllers, or supervisors. These roles are not based on what the component is doing in the real world. Instead, they are based on how each component interacts with all of others in the network. Now let's describe each one of them. The devices are standalone units designed to communicate real-time information to controllers. They don't try to communicate with other devices directly. Instead, they report the real-time data, same as cyclic data, directly to controller, and they also may send some alarm or diagnostic data, same as cyclic data, to the supervisor. Controllers are aggregators for real-time data, the cyclic data, sent by one or more devices. They keep up not only with the device's real-time data, but they collect information about each device's maintenance status. They collect alarm messages. They make all the information available for the end users. And collectors are typically PLCs, the PC software applications, or high-end HMIs. Now, supervisors are similar to controllers, but they don't have access to the real-time data from any device. Supervisors are not only the daily, they are not the part of the daily operations of the Profinet network. Instead, the end user may use supervisor to do things like read diagnostic information from the device, assign IP addresses or DCP station names, or troubleshoot a pneumatic network connection. Now Ina will continue with pros and cons.
Let's now talk about pros and cons. Profinet gives you new ways to boost your productivity with 4 decisive advantages: openness, flexibility, efficiency, and performance. Profinet enables quick and secure data exchange on all platforms and creates the possibility of realizing innovative concepts for the production and processing industries. Due to its openness and flexibility, Profinet offers users a high amount of freedom when designing machine and system structure. Profinet's efficiency ensures that the user's available resources are optimally used and that system availability is increased significantly. The performance of Profinet sustainably increases productivity in the company. Profinet creates the basis for a uniform machine plant automation network to which automation devices and standard Ethernet devices can be connected, enables configuration that are independent of the type of controller and other nodes, and protects your existing Profibus investments. Profibus is based on standards and modularity. User benefits are ease of use and flexibility. The single communication protocol enables fully integrated solutions of continuous as well as discrete and safety-related processes to run on the same bus. This eliminates the need for separate systems and allows hybrid automation. In process automation, the device profile ensures compatible device behavior on the bus, enabling the user to choose any profile device of his choice. The operator can detect the status reliably and react appropriately. Efficient industrial processes require high machine and plant availability. The integrated redundancy of Profibus is unreached when it comes to uninterrupted operation. The result is higher availability combined with reduced maintenance cost. Profibus is optimized for distributed I/O applications. It enables proactive management over the life cycle of a plant. Profibus is also known for its high degree of innovation. User requests are gathered and implemented rapidly. Other examples are high effective redundancy concept and the proxy technology, enabling the user to Profibus system to the Ethernet level. Existing plants can be modernized and expanded at any time with Profibus. Hard technology is integrated easily, safety-related and drive tasks are solved with ProfiSafe and ProfiDrive, respectively. Profibus supports advanced asset management strategies that allow plants and equipment to be better managed and maintained. Profinet uniquely combines the highest performance with highest degree of openness. It enables cycle times down to 31 nanoseconds with unrestricted transfer of standard data in parallel. Profinet thus provides the necessary performance to meet even future application requirements. Let's now talk about close relative alternatives and comparisons with them. Modibus is an open protocol that was designed by Modicon. It is accepted as a de facto standard. It was designed for transmitting non-critical, non-deterministic data between PLC. Profibus is a proprietary protocol which is owned by Profibus International Organization. It is accepted. It's an accepted industry standard. It is designed for the transmission of real-time mission-critical I/O data. Profinet has many more features than Modbus, such as process automation profile, peer-to-peer, functional safety, controller redundancy, shared device, so on and so forth. Those features enhance the applications that you can achieve and future-proof the system. Also, Profinet is working toward the future goals such as easy integration with industry, TSN, APL, and OPC-UA. On the contrary, the Modbus organization is keeping Modbus TCP the way it is for simplicity reasons. As for disadvantages, Profibus communication and proprietary of Siemens automation, Profibus communication is a GSD file for its components to integrate with the current control system. Maximum speed of Profibus communications is only up to megabytes per second. The Profibus cable is more expensive. Profibus distance extender is more expensive. Profibus works in master-slave configuration, so if master fails, all the slave connected to the slave will not respond. Let's now discuss features and compare Profibus and Modbus. As for a mode of operation, Profibus operates in multi-master, while Modbus operates only on a single master mode. As for use of Ethernet, Profibus cannot operate on Ethernet, but operates on Ethernet, which is not the same as Profibus, while Modbus can run on Ethernet using TCP/IP protocols. As for physical mediums, Profibus is twisted pair and fiber. Modbus does not define the physical medium at all. It defines a message structure that can be used over any physical medium. Modbus is popular among all. As for speed of transmissions, the first one operates at different speeds of transmissions from 1.2 kilobytes per second to 12 megabytes per second, while Modbus supports speed of transmissions up to 115 kilobytes up to 90.2 kilobytes per second. As for distance coverage, 32 stations use Profibus for distances up to 1,200 meters, while 2 stations communicate at speed of 500 kilobytes for distances up to 400 meters. Low-speed transmissions support higher distances, while high-speed transmission supports lower distances. Modbus cable should be less than 700 meters. And the last point is the application. It is very robust protocol, which can be automated, which can be used to automate the entire plant. It is used where there are more points of multiple vendor equipment are to be automated. As for Modbus, it's a very simple protocol which can be used to interface single controller in point-to-point mode of configuration. It is used for small plant automation. So this was all about